Hey everyone, in this video I'm going to show you a nice little data app, a web application for data analysis and for visualization that I've just created using Streamlit. In my previous video I had showed how to get started with Streamlit and create data apps that can be used for visualization as well as for reporting. It served as a really cool dashboard that I showed in the last video. In this video, I'm going to show you how to create a full-fledged application, which will essentially be a multi-linear regression, or you can say a marketing mix model as well. So a marketing mix model or an MMM using multilinear regression or MLR as its basis. So it's not extremely advanced. It's still pretty basic because MLR or multilinear regression is one of the most fundamental regression models, and MMM models. There can be far more advanced machine learning models, but the purpose again is to show you how you can create slightly more advanced and um, you know applications which can be put to daily use as well. So again, it's just really 3 lines of code within the main body. I'm once again using Google Colab here, and that's the best part about it, that you don't have to do too much. It's just 3 lines of code that you have to write. So people install Streamlit. Once you get installed, once it gets installed, you have to fetch the IP4, the IP version 4 address, and this is the IP address that it returns. And then, as you can see, this is this third piece of code here. It is executing internally. It's been 6 minutes that it's already running on my system locally. And before that, though, you actually have to create this app.py file. Once again, something I showed in the last video as well. But this is where you have to put in all your Python code. So this is the Python code that's actually responsible for what's going to be executed. And the rest of it is just getting the Streamlit ready in order for you to run in the web browser. So what's going to happen within the app actually goes in this particular file here. So once again, this is the way this has been set up. As you can see here, is to run locally. I will show in future videos how you can actually create your data applications and actually make that shareable. Right now it is not. In fact, if this session ends, this particular execution ends, and this file also disappears from Google Colab's folder system. But yeah, so once these three have been done, you actually have the URL. This is the URL, and once you click it, it's going to bring you to some an intermediate site, an intermediate page. So I've actually already loaded the app, but if I were to do that again, it would ask you to since I've already loaded it once, it's not asking here, but if I were to start it from scratch, it would ask you to just input this IP version 4 address, and once you do that, this is the app that you're going to see, and it's once again, it's black and white, and I think it's smart looking, and very, very good for visualization and presentation to your stakeholders. So once again, all you have to do here is browse files. As you can see, multivariate regression analysis, and then choose the data set that you want to analyze. So what this does, it gives you the first few rows of the data set right at the onset. These are 5 rows. The data, the code can be tweaked to increase it to more rows, but I think 5 just suffices. This gives you an overview of the data set, and then it gives you totals of each column. So let's just go through the data set quickly. This gives you gross sale, orders, new customer gross sale, new customer orders, returning customers gross sale, returning customer orders, Facebook spend, Google and Performance Max spend, Google non-branded Performance Max, branded search from Google spend, and then video spend. So these are the different channel spends. So what we're trying to do here is run a regression analysis and try to see which of these channels is actually responsible for having the maximum returns from from maximum effect or impact on gross sale. So that is our outcome variable or dependent variable, and we have the spend columns as the independent or input variables. So that's essentially what it is. And this is the initial regression analysis. As you can see, the dependent variable being gross sale, and this is the you might be familiar with this kind of an output if you have run Linest or similar sort of formula on Google Sheets. This is the kind of output that you would get typically. And of course, it contains a lot of information, regarding R squared and F statistic and AIC, BIC, all the important stuff, standard errors, coefficients, T statistic, p-values, and also some information on skewness and kurtosis. But what we're really interested in are the variables. So this is, of course, the intercept of the constant, and we're getting the standard errors, the T statistic, and the p-values, and the different variables as well. So as you can see, the 4-channel spans, like I said, you have the p-values for all of them, and you can, of course, then see which of them are statistically significant. In our case here, as you can see, none of these are, and that's why what I've done here is that you have an option of carrying on with this analysis. There's going to be a lot that can be done here. I mean, it's not like this is the final approach. I mean, MMMs can be very, very sophisticated. You might have to work on the data set, go back and actually rework on the data set, try and look at if scaling is required, because they might not be all to scale. As you can see here, the scales are different possibly, but that's one thing. So you might have to normalize the data or scale the data. You might also have to look at things like heteroscedasticity and see if there's multicollinearity. So once you actually take care of those things, it might be that the regression analysis gives you very different results, and you might get statistically significant output or slope values. But yeah, I mean, those things aside as well, there's another way to actually continue having the making use of this regression analysis, even if you don't get very good p-values at the outset. And that is possible by doing what's called the stepwise regression analysis. So that's when you just keep dropping one variable after another, and the basis of dropping is the least significant variable, or the least statistically significant. So for instance, in this case, the branded search, as you can see, had the highest p-value, meaning that it was the least significant, statistically significant. So that was dropped, and then for the rest of the variables, we did the regression analysis again. So it is all happening in the back end. So this application is doing that on its own, and this keeps repeating the process to, and keeps dropping the next least significant variable, statistically significant variable, and then it finally arrives at a final model, which that's the model, because that actually has only one variable, obviously. So you need at least one independent variable or input variable. And as you can see here, the p-value here is not that bad, right? I mean, if the constant does not have a statistically significant value, this does not have either, but it's very close because it's just barely and marginally above 0.05. So, I mean, that's at the 95 level confidence interval. Of course, for a different confidence interval, you might have slightly lenient requirements for statistical significance, and you might actually have a very different approach to it. But that also has to be hard coded into the code. So as I said, there's a Python code which is working at the back end. This is all doing this. I'm not going into the explanations, but as you can see, there are functions to calculate the regression metrics, and there's a function to load and pre-process the data. Before that, there's the residuals will be plotted. I'll just show you the plots as well. So upload a file and regression analysis, the totals. So all of these are different sections within the code which are actually carrying out the different parts of the analysis. And then the final model metric gives you the R squared, which gives you the overall explainability of the model. That is how well the output is actually being explained, and by this particular model. The F statistic and the intercept, also important metrics, and the slope for Facebook spend, that gives you the actual impact of Facebook spend on gross sales for every unit increase in Facebook spend. And then you also have p-value for Facebook spend, which I said is, like I said, it's pretty close to being statistically significant. So that's the final model, metrics, and as you can see, it's done a pretty neat job here. And all you had to do is just, give a couple of clicks here. You obviously needed that code, and but once you've done that, obviously this is a method, like I said, it's being run internally. but it has a great look and feel to it. So you can always make this shareable, and there are ways to make that shareable and make it available to run from any system and not just locally from one computer, as is the case now. Anyway, so there are also residual plots, as you can see, which gives you the plot between the residuals, and the residuals are nothing but the errors, and then the x-axis has the predicted values. So you have the plots between them. You also have the normal probability, or the QQ plot, which actually should be, which basically shows how well the assumption of normality or normal distribution is, whether or not that assumption really holds, and that is the best case scenario is when all the points are actually um, closely aligned with this red line here. Unfortunately, as you can see here, it's completely off from that. So the normal probability plot shows that the assumption is probably not very good. So multilinear regression, at least in this format, is probably not the best choice of a model. But this is just meant to be different for different data sets, right? Not every data set will be easily and as well explained by any model. Different data sets will have different kinds of models required for them. But this is just an example, right? So and then you also have the predicted versus the observed plot, when you have the predicted values in the y axis and the observed values in the x-axis. So that also shows you, how well the prediction has been, and as you can see, there is some dispersion around it, so it's not the best prediction really. But nonetheless, you have got an idea of the power of Streamlit. It has a very powerful, um, sort of framework. It's a Python framework, and it makes room for creating such really powerful applications which will be shareable. So as you can see here, this can be browsed, and you can just upload your own files here. So that is essentially what I've shown so far. I will show probably in future videos how to use this in the form of integrations as well with other applications, and that will make use of APIs. And for that, of course, you'll have to dive deeper and make use of developer access tokens and API keys and all of that stuff. But for now, this is what I had to show. Really good stuff from Streamlit. Completely free to use, and I think you guys should definitely give it a go. Do let me know if you liked it. Like, share, and subscribe if you enjoyed this video, and stay tuned for future content. Thanks a lot for watching.